Hi there, this is Prathamesh, and in this session, we'll learn more about load balancers. Before we take a look at load balancers, let's try to understand how banks provide service to its customers. The last time when you visited a local bank, you may have noticed a teller, also known as a cashier. They essentially serve customers by completing account transactions. They provide services by receiving deposits and loan payments, cashing checks, and issuing savings withdrawals. Each of these transactions can take anywhere between 2 to 10 minutes. Now, if you have 100 people standing in a queue, the teller who is providing the service will soon be overwhelmed and may not be able to provide service to customers in time. In order to resolve these issues, banks provide a service which is similar to a load balancer. In this case, instead of one teller, there will be multiple tellers who will provide service to end users. Now, the work of providing the service to customers is distributed amongst three tellers. This distribution is done using a load balancer. In this case, one of the bank employees will route customers to appropriate tellers and will play a load of load balancer. Thus, they are not able to provide timely service to customers, but they are also ensuring that none of the tellers are overwhelmed and exhausted. This improves their performance and customer service. Now let's take a look at the software systems. Let's say multiple users are trying to access a web-like Gmail app. In this case, if there was just one Gmail server in the world and all the servers were trying to access this server, that would greatly impact the performance of this server and will result in long delays. How can we solve this problem? Our new friend load balancer comes to our rescue. What if we added a load balancer in front of these servers? Now the load balancer will distribute incoming requests amongst a group of servers. Thus, the users are no longer required to wait in the queue, since we are able to scale our systems and serve more users. So, here are the benefits of using a load balancer. Load balancer allows us to add more servers as needed, and thus we can easily scale our web apps as we add more users to the system. Next, it improves availability. If one server goes down, the load balancer can forward the corresponding traffic to another server and thus it prevents outages. This will ensure our users are not impacted due to an outage of one or few more servers. Next, it also improves latency. Due to the addition of new servers, requests are now processed at a faster pace since more servers are able to serve end users. This minimizes delay and ensures real-time service for our end users. Last but not the least, it also provides reliability. An outage of one server won't impact the performance of another, and hence we are able to maintain a high reliability with the addition of a load balancer. Now let's take a look at some of the algorithms that are used by a load balancer. So the first algorithm that we're going to discuss is round robin. In this case, the requests are distributed in a sequential manner. First, the request is received by the load balancer, then it is forwarded to server 1. The next request that is received by the load balancer will be forwarded to server 2. The following one will go to server 3, and the exact same pattern will be followed to handle the next set of requests. This is a simple algorithm, but what are the downsides of using this algorithm? It assumes all the requests that are handled by the load balancer are equally heavy, meaning all the requests will consume same amount of CPU power and hard disk power. In reality, that's not the case. Request 1 could be related to some social media post and may need a low power. On the other hand, request 2 could be related to a video call which is made by another social media user and may need high power on the CPU and the RAM side. Posting a message on the social media is a simpler request and will need less number of resources versus a live streaming session that will be joined by 1000 users. To solve this problem, we can use the least resource algorithm. Let's take a look at that. In this case, the incoming requests are sent to the server that has a maximum number of free resources, such as CPU power, hard disk capacity, RAM, etc. In this example, you can see server 1 has only 20% resources that are utilized, server 2 has 90% resources that are utilized, and server 3 has 10% resources that are unutilized. So, in this scenario, clearly, server 2 has maximum number of free resources and hence this incoming request is sent to server 2. I repeat, server 1 has 20% resources that are not utilized, server 2 has 90% resources that are not utilized, server 3 has 10% resources that are not utilized. Hence, in this case, server 2 is the server that has the most number of resources that are available. So the incoming request will go to server 2. With that being said, let's take a look at the next algorithm. The third algorithm that we have is known as least connections. In this scenario, incoming requests are sent to the server that has the least number of connections. Let's say server 1 is handling 10 requests, also known as connection. Server 2 is handling 1 request, and server 3 is handling 1000 requests. Now, the incoming request received by the load balancer will be forwarded to server 2 since it's only processing 1 request at the moment, while the remaining servers are processing way more requests. So, in this scenario, requests will always go to the server that is processing least number of requests at any given point of time. If you understood this, let's take a look at the last algorithm. This algorithm is known as IP hash. This is a simple algorithm. In this case, all the incoming requests will be routed to different servers based on the IP address that is mentioned in that request. The advantage of using this algorithm is, let's say if you have a web application where you want to ensure that the requests that are received from a certain set of IP addresses are given to server 1, the next set of requests that are received from a certain set of IP addresses are handled by server 2. So you can do a mapping of IP address to server using this algorithm. The advantage of this algorithm is this comes handy when you have an application where you have to do this kind of mapping between an IP address and the server. The disadvantage is you will have to keep a track of every IP address, of the request that is received from the client, and that can add a little bit of a delay. So, with that as a background, let's move on to our next slide. So, in summary, we have studied what a load balancer is, when to use a load balancer, what are some of the benefits that a load balancer provide. We also learned that using a load balancer is more of an art than a science, and choosing an appropriate load balancer is a key. Choice of appropriate load balancer is key for a strong system design. When you choose a load balance algorithm, you're essentially making a trade-off on simplicity of execution versus application performance. Typically in the industry, round robin and least resources are the two algorithms that are commonly used. That's it for this session. Hope you enjoyed this session. I'll see you in the next session. Stay tuned.